So this triangle has two sides that we know are given and then has one angle. The angle is not in between the two sides, so this is an example of a side-side angle triangle, right? And just looking at the three tools we have to solve non-right triangles: law of cosines, law of sines, interior angles, you'll see that this type of triangle belongs to the class of triangles that can be solved using law of sines. We do not have to use the law of cosines, which is good because the law of cosines requires more work. However, there is a danger with side-side angles, right? Um, and that's because you can imagine we're given this side, we're given this angle, and we're given this side. But how do we know that the triangle doesn't look like this? Right? Because if you notice, the two sides, the B and C in this case, could be, they could look like this, they could look like this. Right? We're not told the length of side A, and so we don't know that. All right, so there's two possibilities, right? It could be a triangle like this or a triangle like this. Now, if we have a picture of the triangle and we know which of these two angles, A or B, is the smallest, then what we need to do is find that one first using the law of sines, right? And so if we know that B is a smaller angle than A, then we just ignore angle A for a while and we find angle B first using the law of sines. So let's do that. Now, if on the contrary, if we use the law of sines to find angle A, then we would find this triangle, right? And so if you're not given a picture of the triangle, what you'd have to do is solve it two different ways and get two different triangles. All right, but since we started with this picture, we're sure that the intent is that angle B is smaller than angle A, and so we're going to start with angle B. All right, and if you're confused, just realize that if you know which angle is smaller, find that angle first with a side-side angle. All right, so we'll use the law of sines. We know both the angle and the side across from the angle here, so we can use the law of sines to find an unknown. In this case, B is the unknown. So multiplying both sides of this equation by 12, the 12s will cancel out on the left side. Gives us sine B is equal to 12 sine 25 over 6. So at this point, we have to use inverse sine because we're looking for an angle, and we need to get that angle on the side of the equation by itself, and you isolate it. So the inverse sine and sine cancel out, and you get B is equal to the inverse sine of 12 sine 25 over 6. That's something that we can put in the calculator. So we put that in the decimals calculator, and we get 57.7, right, if we round it. All right, so now we have two angles, and we can find the third angle using the fact that all the interior angles have to add up to 180. All right, now the reason we didn't want to use law of sines here is because we get to a point where there's an inverse sine. And when there's an inverse sine, there's actually two possible answers. There's one in the first quadrant, one in the second quadrant. If you've learned enough trigonometry, you know that. But the Desmos calculator and most calculators would only give you the one in the first quadrant. Meaning it will only give you the value that's less than 90 degrees. All right, and so we would actually get a wrong value for A if we use the law of sines. So instead what we did is we found angle B, and then we're able to put it into this equation and find the correct angle A. All right, subtract 82.2 on both sides. You get that angle A is 97.8. Now there's only one thing left to do, and that is to find side A. All right, and we're going to use the law of cosines again. And this time we are going to use the A's because we already know what we've already found angle A. And so we're going to isolate side A on a side by itself, multiply both sides by A, The a's cancel out. You get that right there. And then we need to multiply by the reciprocal of this fraction to get rid of it. So that cancels out. So we get a is equal to all of that, which we can put into a calculator. So we put into Desmos. Get 14.1 when we round it. And so that is the missing side. So we were able to find all the angles, all the sides. The way we did that is we first used the law of sines, and we found the smaller of the two remaining angles. Then we used the sum of interior angles to find the larger of those two angles. Then we used the law of sines to find the missing side. Right, and so that's how you would solve a side-side angle triangle. All right, hopefully this helped, and hope to see you all in another video.